This will go under the letter P, but there's 3 different names for it. Different people, different books call it different things. We've got prime factorization. We've got product of primes. Oh, by the way, this is, make sure you put AKA. AKA, it's also known as a factor tree. Okay. And it'll be very useful to you in your life. What you are doing with all of these, remember yesterday when they said to make 9 so that it is a product of 2 prime numbers, or what 2 prime numbers would you multiply together to get 9? And you said, oh yeah, 3 times 3. And remember they said, what products would you multiply together to get 12? What prime numbers? And some, and I said 2 times 3, and somebody said, could you have 2 times 3 times 2? And I said, yeah. This is what's called prime factorization, or product of primes, or you could call it like a factor tree. And the reason they call it a factor tree is if you need to prime factorize, let's do this. Let's say I said prime factorize 24. It's called a factor tree because you start with 24 and then you break it down like branches of a tree. What times what will give you 24? There's no right or wrong answer as long as it does give you 24. Julia, you could have
6 times 4.
6 times 4. Okay. So now we've cut 24 into 6 times 4. We're not looking at 24 anymore. You look at the 2 new numbers and you say, are those prime numbers or not? Can I break those down some more? Sure. What times what gives you 6? Brooke?
3 times 2.
3 times 2. And you forget about the 6, it's no longer part of the equation. Are 3 and 2 prime numbers? Can you break them down any more? Well, what about 3 times 1? Yeah. 1's not a prime number, we just talked about that. Okay, and number 2, you would never stop, because you do 3 times 1, and then you'd split 3 down to 3 times 1 again, and so you don't use 1s ever in this. Yeah, you stop with 3 and 2 here, and then you break down 4 into what times what gives you 4? Andrew?
2 times 2.
2 times 2. Don't think about 4 anymore. Are these both prime numbers? Yes. And then when you're done, just because I'll read them like this, please take all of your numbers and put them in order from least to greatest. It's 2 times 2 times 2 times 3. This is the prime factorization of 24. 2 times 2 is 4, times 2 is 8, times 3 is going to give you 24. And somebody always says, well, but what if I would have started with not 6 times 4, but 8 times 3? Well, if you start with 8 times 3, you stop at 3 because that's a prime number. You can break 8 down into 2 times 4. You can stop with 2 because it's a prime number, but 4 gets broken down into another 2 times 2. You still get 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. This is product of primes. Oh, you know what else I did? We got to write in here also is put on here division by primes. This is all the same gobbledygook. All 4 of these things. Division by primes, children. There's two ways to prime factorize. One is the factor tree, that's this. The other way is division by primes. And just like it says, what you do is you look at 24 and you just keep dividing it by a prime number. And the best thing to think about is if it's an even number, divide it by 2 because 2 is a prime number and it's easy to come up with half of 24. So you do this. Okay, 2 goes into 24 12 times. 2 is a prime number, so that's good. Then you divide 12 by a prime number. And again, as long as it's even, I keep dividing it by 2. 12 divided by 2 is 6. 6 is still even, so I divide it by 2 and I get 3. And then once you end up with a prime number at the top, you can stop. Because it's 2 times 2 times 2 times 3. Same thing as the factor tree, just doing it by division. And you might want to do the division thing like if you come up with 124. Okay, because you might not know what times what gives you 124, but you know it's an even number, so you can divide it by 2. What's half of 24, anybody? Yes, 62, whoever said it, but didn't want to say it out loud. Still an even number, so you can divide it by 2 and get 31. I think I wanted to do a different number, but is 31, can I break 31 into anything? Believe it or not, you can't. So unfortunately, I didn't pick a very good one. My answer to this is 2 times 2 times 31. I should have picked one like 144. Oh, what about 100? Let's do 100. We'll do it both ways. 100 division by primes. Cut 100 in half and you get 50. Cut 50 in half, you get
25.
What can I divide into 25 that's a prime number? 5. And I'm left with a 5 on top, which is a prime number. So all of these are my answer. 2 times 2 times 5 times 5. That's division by prime. If I did a factor tree, what times what gives me 100?
10.
10 times 10. Is 10 prime? No. What times what gives me 10? 2 times 5 and 2 times 5. Make sure once you do this you don't go back and look at those because there's no, and then these are all prime numbers, so you end up with the same thing. So you end up with 2 times 2 times 5 times 5. See the difference between the tree thing and the product of prime? Let's do one more here. I'm going to give you this one. Do 1,000 for me. Prime factorize 1,000. And I'll let you pick if you want to do the tree thing or if you want to do division by primes. The tree thing or division by primes. Give me a second. Tree thing or division by primes. No? Shouldn't take too long. Yeah. Most of you know. Should be known. Bella Nuzzo, which way are you doing it? Tree thing or the other way? Division way or the tree thing? You doing branches or are you dividing it up?
The tree.
Alright, so let's do it that way. What times what did you say gives you 1,000? Times.
Wait, what?
What times what gives you 1,000? Times. 100 times what gives you 1,000? I'll go with that. You're right. It is 100 times 10. Okay, are either one of those prime? No. So then what did we break down? 100 is? What times what gives you 100?
10.
times 10. How about 10? What times what gives you 10? 5 times 2, wonderful. And again, we don't need to worry about this anymore, nor that. Sorry, 5 times 2. Alright, what about these 10s, Bella? 5 times 2 for each of them. And that, ladies and gentlemen, would be all of your answers. You would then rewrite it as 2 times 2 times 2 times 5 times 5 times 5. That is 1,000 prime factorized. Everybody get that?
I got that.
Everybody do it as division by primes? If you're dividing it out, and again with big numbers I might think about doing it this way, I don't know. Cut it in half, you get 500. Cut 500 in half, you get 250. I don't know if you're going to cut 250 in half to get 125. And then because it ends with a 5, you divide it by 5, and that gives you 25. And then divide 25 by 5, and you end up with a bunch of 5s and a bunch of 2s. All that way there. Man? No. Landon asked a question here, and here's where you have to be careful. He said, I divided this by 25. It's division by primes. So you always need to divide by a prime number. And 25 is not a prime number. So you're always going to divide by either 2, 3, 5, 7, 11, 13, 17. Probably usually 2 3s and 5s and 7 maybe. Logan?
I started dividing by 5 cents.
It doesn't matter. You'll still have to end at the same. Just make sure at the end you order these from least to greatest. You can do it any way which you order.